3, 4. A little flaky. Hello? Yeah.
Is everyone here? Can everyone see what it's about to show?
I can hold it up a minute.
Okay.
There's a loose connection here.
Grab it from the connection itself.
Just hold it down like that. Yeah, there we go.
Yeah, there you go.
Hello again. Go.
You're good to go for me?
Okay. My name is Jim Phelan. I'm the Mars Rover project lead for Houston Robotics. We meet down the hall here every Saturday, starting about 9 o'clock till about 3, and we work on a bunch of robot projects. At the end of July of last year, NASA and the Jet Propulsion Laboratory released the plans online for the open source Mars Rover. You can just Google JPL open source Mars Rover, and it'll lead you to a page with a simulation and so forth, and then that page, if you're interested, will take you to their GitHub. Y'all know what a GitHub is?
No.
Nobody knows what a GitHub is. A GitHub is an online, basically a repository of information. It's a place where people can put their code, texts, so forth, and other people can join in and change the project, add to it, make comments. It's sort of a serious maker's social media, primarily around software development, where there's like multiple changes in software, but it can be about any kind of project. If you go there, you can download the manual, and in this manual, it gives you the complete parts list. There are about 1,000 individual parts, about 100 different line items of kinds of parts, from about a dozen different sources. It tells you the sources, how much it costs, everything you need to know, and then there's all the build instructions in here on how to do the electronics, the mechanics, each part of the mechanics, the arms, the body, and so forth. So if you want to build one of these yourself, you can do it. Everything is online. The total cost is about $2,500 if you want to buy all the parts. These are all open source, standard, off-the-shelf stuff. There's nothing custom-made here except for these 3D printed motor and encoder holders that were specially designed, and the head, which I don't have stuck on here, but the head which holds an LED display is also 3D printed. And the back panel is laser cut acrylic, so they can make it look cool. They can see the insides of it. I left the wheels at home. I wasn't expecting to do a show and tell today. Currently, testing 1, 2, 3. Okay, we're back in. Currently, I'm working on some motor control issues. I had problems getting the drive motors. There's 6 drive motors, 1 for each of the 6 wheels. And there's a motor controller, which is supposedly an intelligent motor controller, where you can tune the motors so that each motor is a little bit different, because all manufactured things are just a little bit different. Well, the idea of tuning the motor is to get all the motors, at least the ones on opposite sides, to perform exactly alike. So by tuning the motors, if you say, I want it to go 1 meter per second, both wheels will do that. I was having trouble getting that tuned. I would try to tune it, and it would wiggle back and forth, and it would just stop. Well, after discussing with the people who make the motor controllers, I found out that one of our settings was wrong. I changed the setting, and now everything's good. Now I'm having trouble with the steering motors. Just like the regular Mars Rover, there are 4 steering motors, so you have 4 wheels that control what direction you're going in. So if you want to go in a sharp circle, the 2 wheels will turn, the 2 back wheels will turn the opposite direction, spin in place. And right now I'm having issues with the absolute controllers that are telling the motor controller exactly what position the wheels are in. So anyway, that's the spiel. Do y'all have any questions?
So you're doing this because for fun, for responsibility of winning something to actually send this to Mars? Why?
It's the Mars Rover. What more do you need? It's cool. It's space. I've wanted a Mars Rover ever since they announced it in NASA before the first one took off. Like, that is so cool. I want one of those. And when they released the open source plans, we just said over lunch one day, we've got to do this. But the long term is, one is a great robotics platform. The plans as they're given in by NASA with the JPL, which is there's basically a couple of interns that had a summer job or a one-year internship job for Jet Propulsion Laboratory, and their project was to they wanted to do outreach from NASA and say, hey, we want to get more people involved in space stuff, and so why don't you guys make an open source version of the Mars Rover? And apparently they did one in the past that was like $25,000. So now this is not going to work. Not many people are going to do this. Let's simplify it. Let's break it down and try to have something that ordinary people might be able to do. And so that's these two interns basically did that as their project, and now they're hired by NASA to continue the project.
Is this to scale or is this a smaller?
This is much smaller. The actual Mars Rover is like the size of a car. It's big. So this is, I don't know what the actual fraction of the scale it is, but it's a lot smaller.
So you work on this every Saturday in this building?
Mm-hmm, and a lot at home.
And a lot at
Thank
home.
you.
But because it's open source, other people can also learn how to do this. Is this skill any valuable to learn?
Mm-hmm.
After I do this, put it in my closet. Why should I? Have I learned anything in the process?
You've learned a lot in the process. You learn a lot about mechanics. You learn a lot about physics. You learn a lot about electronics, basic power, electricity. Their version is a remote control only. It's learned by a Xbox controller. Our plan, we have named this one Fidelity because we want to be as faithful as possible to the NASA JPL plans. We've made our own little variations already just because you just have to. But we're going to make a new version of this once we've gotten this one up and running. First make it run, then make it better. The next one is going to be called Audacity, and we're going to call it that big. But sensors, cameras, maybe a moving arm, artificial intelligence, self-driving, and we're going to call that one Audacity because we're just going to improve the heck out of it.
So if I do nothing else and I just work on this over the summer with you guys, just watching and learning, can I get a job anywhere?
No guarantees of that.
But
you will have a lot of skill in robotics and mechanics and motor control. If we get all the way to self-driving automation, we're going to be working on a simulation, like getting a gazebo avatar. Gazebo is a simulation platform where you basically create an online model of whatever it is you have, and then you can run it in simulation. So you can run your code that would be on the robot, except you run it in simulation so that if it crashes into something, you don't actually crash your own robot.
wow. Nice.
The other reason for doing this is this is just a basic robotics platform. So once you have this, then you can build on it and build on it and build on it and have more sensors, actuators, intelligence, and that sort of thing.
Awesome. So if you guys wanted to come see it, there's literally a motor here, a motor here, a motor here. It moves even at that edge. So it's got a lot of, what do you call it, angles, a lot of...
well, there's 10 motors.
It's not like a typical car, where this goes straight and left and right. This can go in all directions.
And the other interesting advantage of the Mars Rover, I don't know if you've heard of the rocker bogie suspension system. I need to put this thing down.
Okay.
Work.
Yeah, I think it's now loose.
Anyway,
Just
I'll just talk loud.
Thank you, sir.
Can you all see this? As this thing goes
Pretty heavy.
up and down hills, Because if you move one side, the other side changes.
Ah, it's like
So as this thing, and this can rock back and forth too. This is, I think this back here is called the rocker, and this is the bogey.
Wow.
So that as you're going along, you want to climb over a rock on Mars, and this wheel has to climb up and go over the rock. It keeps the other side down on the ground, so that all 6 wheels are intact with the ground. And as it goes along, it goes over the rock, and this wheel goes up, and this wheel goes up, and so the whole suspension is designed to be a good climber.
Wow. It looks to me like a spider.
Kind of, yeah. Except that it's going to have wheels and it's not, articulated. There are hexapods and octopods and quadrupeds that actually walk, but this is not one of them. It's less efficient than rolling on wheels, so that's why NASA decided to do it this way.
Awesome. So any questions? You guys have this pitch competition, right? Now, believe it or not, but a lot of technology that we're utilizing today came from other fields in science, in biology, anthropology. Just think about things like the internet, right? You guys all use Wi-Fi? Yes? No? Okay, do you know the technology in Wi-Fi was developed by studying ants and how ants communicate? Have you ever seen where if one ant found the food, every other ant in the colony knew where the food was without the ant actually having to go back to tell everybody? It's using nodes. And using that technology is how we get our Wi-Fi going. That to me looked like a spider as you're talking, but it would make sense. When you don't know what the environment would look like, wouldn't you want something like a spider so it can maneuver in all different ways? Association is a great skill for innovation, is what I'm getting at. Taking something that you know about, applying it to something you don't. So when you don't know anything about robotics, but you know something about, dogs or cats and their behavior or their animals, right? Or you know something about how things fly, you could pitch ideas about implementing those things towards making it better. Innovation is nothing more, it's creativity that works, right? But it's creativity that works for the right people, for the right time. And it's not like discovering a new element. It's basically taking 2 discovered things already, combining it together. That's really what an innovation is, right? You're just taking different basic sciences to merging it with some problem you're trying to solve. So if you're thinking about looking for ideas for, let's say, space, study spiders or animals and think about how can you create something so that it can also survive in an unknown hostile environment. Spiders also protect themselves, right? Little ants survive on our planet, and so does the big elephant. There's a lot to learn just by observing, which is another skill of innovation. Observe, right? So associate things, observe things, question. Jim right here has spent many, many years of his time and his passion for robotics. He's part of the Houston Robotics. They meet every Saturday. No one pays them to do this. Spending his own money to do this because that's his passion. He questions, why doesn't it work? Right? If you like something, you like cars, and your car breaks down, don't you want to know how to fix it or why it broke? Your AC because you need it in the summer? You question. You try to answer that question by trying to do something about it. And I envy you, dude, because that is awesome. I wish I could do that, right? Yeah. I can. I just have to spend time. I'm more passionate about something else. So absolutely, this is awesome. So questioning is a third skill, right? By really just asking why, how, what, when, things you already know. All right. Jim offers a perspective. I don't have to learn about this, but if I network with Jim, I'm Ravi. My story is I'm an educator. I do coding. I'm a coder. You're a hardware guy. If I don't know something, because we've networked, now I can ask him. And if he has ever a problem with any of his codes, he can say, hey, Ravi, can you check out my code? I wrote this. Something's not right. The point is, I don't have to know all the answers. I know someone who does. That's the skill of innovation. Networking. You should network. Get to know people you wouldn't hang around with because they're different. Because they have a skill that you don't. But leverage it because that's how you become innovative. That's how your team can support each other. Am I doing so far?
Absolutely right.
I got one more.
Everybody in Houston Robotics has a different skill. We have 12-year-old kids that come in there and are just amazing with electronics. We got 80-year-old people who are in there. We got people from every flavor you can imagine, and we're not there because we want to be diverse. We're there because we want to do robotics and artificial intelligence. But by bringing people together with a common idea, you get everybody together. And nobody knows everything about robotics. So, like exactly you say, we got coder people, we got mechanical people, we got AI people. It's a great thing because just the energy in that room is tremendous. Because people says, hey, did you hear about this new widget that's some kind of microprocessor? Like, I never heard of it, but it sounds really cool. And so I learned a little bit about that.
Yeah, so then the fifth skill, right? So far, we've got association, observing, questioning, networking, but then the most important skill of them all, experimenting. If you don't do anything with it, you don't take action with stuff, it doesn't matter. None of those skills matter. If you don't take initiative to make friends, networking doesn't matter, right? So you can't just go and give a business card to everybody and say, I've networked, I'm done, I'm going home. It doesn't work. You have to experiment, you have to have a conversation, you have to get your hands dirty. Does that make sense? You have to build stuff. So, I'm sure you failed a couple of times in making that thing work, but then look, you've got a lot further because you experimented. I think that's something that innovation is all about. We know our goal, right? I shared that in the morning. We know our goal. How we get there doesn't matter. As long as we know we've tried multiple ways to get there. So I encourage y'all, right? This is a resource in our community. And I'll tell you that it's a very rare resource in our community. Because, so you guys used to be at a whole different venue somewhere else.
Used to be over at TXRX.
TXRX, okay.
But
so
we
maybe
got
some of them
partnered in with HCC because we had some people that belong to HCC. And they kind of say, hey, we have a great facility over here. We have a fab lab. We can do stuff. We have a classroom because we're getting kind of crowded. Why don't you come on over and check it out? It's fantastic.
So here's an opportunity for you on HCC campuses. You've got folks like Jim working on projects like the Mars Rover. But until you get yourself out there and try it and experiment and the other skills, we're not doing it. So that's what I'm going to leave you with. If you have any questions for Jim, he's here. But if you want to go check out all the cool things the entire group is doing, is down the hall in
E122.
In 122.
First classroom on the right, you go down the hall. You can't miss it.
Yeah, you can't miss it. So thank you so much, sir, for doing this. And because you've done this, I want to
this is one of our bigger projects. We have lots of little projects for people who don't know anything. One of the things is called a sneaker bot. You take a cheap radio-controlled car, you rip out the radio-controlled guts, you put in a small Raspberry Pi Zero, a motor controller, a little breadboard, and all of a sudden you have a run it by yourself autonomous car. Well, you've had to put sensors and stuff on there, but we've got a Go kits that will take you from a basic platform and add sensors and go on from there.
So, as a token of my appreciation from Houston Community College, thank you for sharing your project with us. It's a cool little iPad bag, sorry. But you can use it for other things. It's got a strap as well. But thank you, and we'll just take a quick photo. Thank you. Thank you so much. But if you want to check them out, go down the hall.
One of our members is going to give us a little talk in just a second.
Is that right?
There it is. All right. So, look at your sundials, your watches, your clocks. It is 2:27 right now. Yeah. 2:27. So we're giving you about 30 more minutes to work on putting the finishing touches on your rockets. If you want to test it, go ahead and test it.